Welcome to Prime Thing. The moon is now valued at $170 billion annually, and everyone wants a piece. The United States is poised to take the largest share. But why is the moon suddenly so valuable? In a recent study commissioned by DARPA, PricewaterhouseCoopers projects the lunar market could reach $170 billion a year by 2040, potentially escalating to trillions later. To learn more about DARPA, please watch the video linked in the description. As mentioned in some of our previous videos, the new moon rush is on, with the US, Europe and China all investing billions. This time it's about long-term human settlement and private companies playing a major role. However, the cost of sustaining a presence on the moon is very high, as food, water and fuel need to be transported there. So every payload that doesn't have to be transported from Earth to the moon translates into savings worth millions. If we could solve for the primary enablers, fuel and water, we could revolutionize the future of space exploration. Today, we'll explore two key lunar resources with the potential to transform both the moon and global economies. But before we jump in, please do subscribe to our channel. Your support encourages us to keep making these videos. Thanks. All recent moon missions, when viewed collectively, aim to establish permanent human settlements on the moon. This means a huge increase in demand in the emerging lunar economy, from both government agencies and commercial enterprises. Private companies alone are expected to potentially gain contracts exceeding $137 billion from lunar activities over the next 5 years. Whether it's space agencies like ISRO and NASA, or private companies like SpaceX and Intuitive Machines, they all share a major goal: locating sources of water ice and energy resources on the lunar surface. Water ice is frozen water found in the permanently shadowed craters of the moon's south pole. The confirmation of widespread water ice has made that region a prime target for recent and upcoming missions, as it can provide drinking water for future lunar habitats and be split into hydrogen and oxygen, rocket fuel components. This is absolutely crucial for future space exploration. A fuel source on the moon would drastically reduce exploration costs by eliminating the need to haul fuel from Earth. Hence, water ice is key to establishing a permanent human presence on the moon. While water is the most sought-after resource, these missions also investigate exciting energy sources like helium-3, an isotope rare on Earth, but present in lunar regolith, the dusty moon soil. Helium-3 stands out as a potential fuel for future nuclear fusion reactors, offering a nearly limitless supply of clean energy. To give you a sense of scale, just 25 tons of helium-3 could power the entire United States for a year. This is just 0.0025% of the total helium-3 estimated to be on the moon. With multiple space agencies and private players joining the hunt, the moon's polar regions have become the focus of intense scientific study and exploration. The goal is to extract these resources to power humanity's return to the moon after over 50 years. The most promising lunar resource for economic exploitation are the estimated 600 million metric tons of water ice. Converting this water ice into hydrogen and oxygen could create rocket fuel right on the moon, making mining and transporting payloads to Earth far more economical. This would be an absolute turning point for moon missions. NASA estimates that sending a payload through its CLIPS program to the moon currently costs about $1.2 million per kilogram. In February 2024, Intuitive Machines' Nova C lander carried NASA's ice prospecting experiments and made a historic landing near the lunar south pole. Despite tipping over, they delivered this payload for about $1 million per kilogram, marking a significant reduction. India's Chandrayaan-3 mission, completed at just $75 million, brought costs down even further to around $19,000 per kilogram. This success story is a testament to India's frugal engineering, reusing components and leveraging domestic launch vehicles. Shocked and inspired in equal parts by this, NASA now aims to reduce payload costs to $100,000 per kilogram within a decade, and potentially as low as $300 per kilogram in the future. This means that spacecraft refuel with lunar propellant, thus potentially saving $100 million per mission. AI and machine learning are key to making this vision a reality. These technologies help us understand the moon's environment, figure out how to extract resources, and find the best ways to mine water ice. Scientists are confident that it's not a matter of if, but when water ice mining will start. These cost reductions could transform lunar missions from ambitious dreams into profitable ventures. The regolith, the Moon's top loose and dusty layer, consists of unconsolidated material covering solid rock. This lunar regolith hides many minerals and metals that are rare and valuable on Earth. From diamond, graphite, gold, platinum, rhodium to lanthanides, the rare earth elements critical for electronics and renewable energy technologies. The list is long, but the rarest and most valuable of them all is helium-3. This stable isotope of helium has a very exciting use as fuel for nuclear fusion reactors, providing limitless clean energy without radioactive waste. While challenges remain in extracting and transporting helium-3 economically, accessing this resource could transform global energy markets if fusion power becomes commercially viable. The Moon's surface is estimated to contain over 1 million metric tons of helium-3, deposited by the solar wind over billions of years. To put that in perspective, the global energy market is valued at over $6 trillion. At current terrestrial prices of around $1,000 per litre, the total value of lunar helium-3 reserves could exceed 4 quadrillion. Harvesting helium-3 alone could generate trillions of dollars. That is 40 times the size of the global economy. The economic benefits of lunar resources could be immense, from alleviating shortages to reducing our reliance on terrestrial mining, which often has significant environmental impacts. With resources like water ice and helium-3, lunar missions are not just scientific endeavors, but potential economic game changers. They could drastically reduce costs and open up a new frontier for human exploration and resource utilization. Fusion power has long been the holy grail of energy production. It's the process that powers the sun, promising nearly limitless, clean energy if we can harness it on Earth. The question is, will it become a reality anytime soon? What do you think? Let us know in the comments section below. If you found this video insightful, please subscribe to our channel. Your support helps us continue bringing you high-quality content.